And welcome to the Daily Space Weather Show. It's a good time to be talking about space weather since there's a geomagnetic storm going on. We've even got some active auroral cams and the most detailed imagery of the sun you'll find in the known universe. Coming at you here from the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. This is the past 24 hours, and you might see a large coronal hole right there in the Earth-facing portion of the solar disk. It's in many ways the main feature, and a feature you can continue to expect to see over the next 12 plus months as we approach solar maximum. Let's take a quick tour of what's going on the closest star. There's an equatorial view for you. SDO 171 plus 211 angstroms. It is November 30th and December 1st. Here's a little closer view of that coronal hole. And you can see indeed a shortage of many species of ionized iron in there. The coronal holes show us the solar polar field reversal process as it happens throughout each solar cycle. Here's the northern hemisphere, and you might see a large plasma filament up there in the northwest. Don't worry, if you'd like a closer view of that, there you go. So that's several tens of thousands of kilometers tall, that solar filament there defying gravity as it's suspended by the strong and jumbled up magnetic fields in the sun's corona. The most active region for the past 24 hours has been this area here in the northwest. There was an M-class flare that came from that area, which we shall show. There is a southern polar region for sake of completeness. Huge plasma filament down there, part of it splashing back down, some of it also ejecting into outer space. And let's take a look at sunspots here for a brief moment. There is November 30th and December 1st to date. And no major changes happening in the past 24 hours, although several sunspot groups have set, while some more have formed up there in the northwest. Indeed, an exciting portion of the sun right now. The sun suddenly creating some sunspots there right in this area. You'll see them form rather rapidly. So we won't see a big dip in the sunspot number despite some sunspots setting. The following are paid endorsements. Consider becoming a member of the Smash Team if you enjoy the content and you want to contribute to the channel. There's a gold level, there's a silver level, there's a bronze level, there's even a gold annual paid up subscription. That's the best value. It's almost like getting 4 months of the gold subscription for free. Smashomash.com/Smash Team. Complimentary merch is included for a gold annual paid up subscription. Get additional content and help support the channel's existence at Smashomash.com/Smash Team. Launched in October of 2021. Another paid endorsement is our merch shop. So today's featured product is the Smash News Network least busted name and news design. If you'd like to go tell your friends and foes about the channel, that's a good way to do it. It's got the YouTube URL of the Smash News Network least busted name in news. So that's a good ad for us, I guess. Sure, why not? We've got 36 other designs there available on dozens and dozens of different types of products from the Redbubble shop. Huge savings there, site-wide. Continue here. You can see 30, 25, 35, up to 60% off on some products there at Redbubble. So go pick up some merch and look like you belong to the Smash Team. Next, another featured product from the Amazon shop is the one I'm currently wearing. There you go. You want to buy one of those? We got you covered. Amazon.com/shop/Smashomash. Amazon.com/shop/Smashomash. Also linked below this very video in the description. Get your radiation reflecting hat. Also, you can find discounts from Hemp Lucid. If you're in the market for some Hemp Lucid products, check them out. Enter the promo code SMASHOMASH10 to save as many percent on checkout. SMASHOMASH10 will save you 10% at hemplucid.com. Thanks to everybody who's picked up products from there. And what else you got? We got more space weather. However, don't forget to visit our links as well, smashomash.com. Smashomash.com, the homepage of the Smash News Network, least busted name in news. Once again, congratulations on realizing that it exists. We remain surprised. Visit us on social media, press, share, like, comment, etc., and let's get back to some space weather. Guess what? We're seeing some aurora over Iceland. So here are some live cams. Check it out, Aurora Cam, folks. How you like them apples? Some aurora happening as we speak. We've got a bunch of different views here from Iceland. Quite the action going on right now. And we'll show one more here. How about this one? Some town with a name I dare not try to pronounce. Langrahirgir. Some aurora borealis there at Iceland. Oh, how about one more? What do you got? What's up with this one? Did we already show that one? There you go. Some green glowing skies. And let's see what volcanoes are erupting. Since that's the reason we had the volcano cams up there anyway. We had the Iceland cameras up for that reason. These are the erupting volcanoes. Etna now back on the list. Another paroxysm there. Abico produced a 10,000-foot ash plume. Popocatépetl a 20,000-foot ash plume. Fuego exploded a 15,000-foot ash plume over Guatemala. Sabancaya exploding 23,000-foot ash plume over Peru. And Erta Ale in Ethiopia there. Lava spattering and so forth. Nice. So, an African volcano there going off as we create the video. Continuing right along to earthquakes. And these are the quakes of the past 90 days. These are the quakes of the past 24 hours. We'll cite 5 or greater magnitudes like this 5.0 at Fiji from late last night, 23:20 Universal Time. Alaska had a 5.0. Shout out to our viewers from Anchorage. Did you feel that quake? Let us know in the comments. California had a 4.8. That's a noteworthy quake, folks. Could be a foreshock. Keep that in mind. Any earthquake could be a foreshock. Chile had a 5.0. That was at 8:45 this morning. And then Chile had a 5.4. Chile in Gansu, where the Ginsu knife was invented. The Myanmar-China border had a 5.0 as well, and those are the quakes of the past 24 of a 5 or greater magnitude. And let's return to space. So that is what's going on the past 24 hours from SDO. Now we're looking at ionized iron and helium, 193 plus 304 angstroms respectively. And let's move to some stats. The 10.7 is now at 162 solar flux units. 162 is the 10.7 centimeter radio flux. There's the 1 year chart to contextualize that. 172, that needs an update. Red line is a sunspot number, black line is the 1 year graph for radio flux. Space Weather Enthusiast dashboard showing continued geomagnetic storm activity through tomorrow around midday. So we may see another pulse tonight, folks. The possibility of continued geomagnetic storms. Don't be surprised to see the aurora even at lower latitudes. I mean, it could be a great example of a night where you could actually see the aurora in Florida. So there you go. Big time geomagnetic storm conditions. We forecasted the most recent CME only hours after it ejected, so I don't know. There you go. And next, Earth's magnetic moment from space. So we like to show this daily on the channel. This is what Earth's magnetic moment from space likely looks like. That is the magnetohydrodynamic pressure of the Earth's magnetosphere, and we've got very dense plasma environment at the moment, and some variations recently happening in the plasma temperature, magnetic field orientation, and more. We'll get to it here in a minute. First, Earth's magnetic moment from the ground. So here are the past 4 hours of magnetic flux density from ground level at North America. And again, some big variations happening here in the past few hours. We'll also show the full globe view as we've got viewers from all around the world. Shout out to our viewers from UNDA. So that is what's going on. And for our North American viewers, try the geoelectric field map for US and Canada. That'll really show you the most likely places to see the aurora. It shows near real-time measurements of induction into the power grid. So I didn't notice any communications breakdowns today. I didn't hear about any power grid out situations. Keep in mind it is springtime in the southern hemisphere, so it is a little more likely for South American grids to have been damaged, but I didn't see even a hiccup in communications in the US. Continuing on, there's the KP index still at geomagnetic storm conditions, folks. KP5 is the current state of affairs. It's fantastic. It's a well-forecasted geomagnetic storm, exactly when people expected it to arrive. So KP7, it was an initial hard hit. Since then, it has not been as hard. Keep in mind, we could see as high as a KP 8.33, in my opinion. That's about the top that you could expect to see. Just a little over KP 8 could happen. Still not outside the realm of possibility. So that's the current state of affairs for the past 3 days. And here's our solar wind from ACE. Let's move on to the Discover, as there's missing data there from ACE. Discover showing about 10 protons per cubic centimeter for the solar wind density. Solar wind velocity here just about 500 kilometers a second. You can see right here we just did have some big variations in the plasma temperature. And we've got a strong field here. So the next update we may see, I'm expecting it to go back up to about a KP 6.66 here, maybe even a KP 7 once again. Check it out. These are the conditions. Okay, they got a little bit stronger there for KP 7. 28 nanotesla for the total field there, and a BZ of negative 26, a very strong negative BZ there. That is the vertical component of the magnetic field. All right, it's not as strong here. We are expecting to see like a KP6. That's my guess. KP6 coming back, folks. So let me check for alerts. Do we have anything? KP6 is coming back. What do we have? Yep, KP6 expected, so NOAA agrees with my forecast there. KP6 likely coming back. And there are some big strikes in the GOES magnetometer. So big variations happening there in the GOES magnetometer. No real surprise there either. And let's bring up the 7-day just briefly, just to show you how big of a variation that is. We saw a big spike there in both the GOES 18 at noontime local time for it, and a big spike in the GOES 16 around noon local time for the GOES 18. So that's what these represent. That's noon local time for the GOES 18. This is midnight local time for the GOES 16. Moving right along to our top view ecliptic. That is the hardest thing to say. Top view ecliptic plane field plot. There you go. Earth is in a South Pole-oriented magnetic sector of the heliosphere. Here's our line of sight field plot. Solar B field in blue, polar fields in green and red for south and north respectively. Photosphere magnetism in grayscale. A great snapshot of what's really going on. And if you're able to read that and know what those data mean, then you are at least an intermediate level heliophysicist. Continuing on, our line of sight ecliptic plane field plot. North Pole sector coming in a day or two. At the moment, Earth is kind of near the middle of a South Pole-oriented magnetic sector. Here's our line of sight coronal hole plot. And let's move. We've got some North Pole coronal holes here rotating into the southeast. Let's move to coronal holes from SDO. There's another 24-hour video for you. And let's zoom in a little bit closer. What evil lurks in the depths of coronal holes? The Smash Team knows. Boo! And let's move to sunspots. So, sunspots. The number has dipped. No real surprise there, although you can expect it to come back up here shortly. Current sunspot number is 134, maybe? Something like that? 134? I'll say 134. That's close enough. And here's our flare probability monitor and scoreboard. Once again, just like yesterday, the most likely place to see a large flare, folks, is going to be in the western limb. 3507 is looking promising. And also keep in mind there is one new sunspot that's going to get named. So this group right here is a new sunspot group. That'll be known as 3510. 3509, I think. 3509? 3509. Anyway, here are sunspots from SDO's perspective. There is the SDO Continuum. That is a 24-hour video from just before we recorded this content. Again, there you can see that sunspot growing in the northwest. So as groups set, more groups form to replace them. It's like a sunspot conveyor belt, folks. Anyway, moving right along to our GOES proton flux, which is flatlined. Little tiny spikes in that there. And we just did have an M-class solar flare. It was only an M1, so 2 M-class flares in the past 24 hours. Let's take a look at the SDO's 94 angstroms wavelength. The SDO 94 angstroms wavelength. Look in the lower left corner there, folks. Such a good wavelength, we had to include it twice. I meant to include 131 there, but I included 94 and 94, which does absolutely nothing. And again, those largest flares did come from exactly where expected, right on the western limb. Yeah, sunspots, they become more likely to produce large flares at the limb. Does it tell us something about the physics? Probably. Will I discuss it in this video? No. Because we have an Ask a Physicist segment coming up. So let's get to that. But first, a star chart. So this is what's going on overhead. This is what's happening over my head in Lehigh Valley, Pennsylvania. Make your own star chart at skyandtelescope.org. We've got some gas giants up there. And here is what's going on in the solar system, our solar system forecast, courtesy of theplanetstoday.com. And here's your solar system forecast for 1 week. That's where things will be on December 8th. We will have a crescent waning moon. And here's the astronomy photo of the day. It's a photo of the core of the galaxy. The Milky Way's central bulge, taken from La Silla Observatory in Chile. Fantastic high-res imagery there of the Milky Way. That is the constellation Sagittarius, where the core of the galaxy is located. The core of the galaxy is known as Sagittarius A star, believed to be a supermassive black hole. let's just call it a massive radio source. That way nobody has to argue about whether or not that is a thing, or whether black holes are science, etc. And we'll be using the word black some more in the video. Because, well, actually not black, just dark. Yeah, dark. Because there's some stuff about dark matter coming up, so make sure you press the like button, folks. We need your assistance to get the video content onto screens. Because, I don't know, because of mysteriously low views despite solar storms coming in. It makes very slim to no sense, folks. Slim to no sense. So press like, press share, press subscribe, etc. Tell your friends and foes about the channel. Become a member of the Smash team. Visit us on social media. And we apologize. We apologize for any inconvenience. However, the video cannot continue until you press the like button. No, that's okay. We'll wait. We've got an Ask a Particle Physicist segment coming up that you too can get involved in. You missed this week's submissions, unless you're one of a couple people, but you could always submit an Ask a Particle Physicist question for next week. In the meantime, just press the like button while we wait for all of the slackers to press like. Smash staff, have they pressed like yet? She claims they have because she likes to lie and cover for you people. I'll just assume that she's not committing fraud and move on to the Ask a Particle Physicist segment. So if you haven't subscribed to Eugene's channel, it's Eugene the Philostopher. 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 The monotone from Minsk, it's Eugene the Philostopher. Make sure you subscribe to the channel. If you want to submit a question for Ask a Particle Physicist, head to smashomash.com/forum. Go to the General Science Forum and click on the Ask a Physicist segment. We might change it to Ask a Physicist, but it's currently Ask a Particle Physicist. So if you don't like it, I don't know what to tell you. But that's what's going on. You want to submit a question, that's the best place to do it, not the YouTube comments. The YouTube comments is a pretty lousy place to do it because while we read all comments, it is YouTube, so it's not optimal. Anyway, here is today's Ask a Particle Physicist segment, and since I've already listened to it, I'm going to leave it up to you. So here we go. Oh, and in the meantime, don't forget to subscribe to Eugene the Philostopher. Eugene the Philostopher. Finally, over 500 subscribers. Congratulations to Eugene. Here is the Ask a Particle Physicist segment of the day, submitted by one of our viewers. Again, if you want to find out who that is, you can go visit smashomash.com/forum. In the General Science Forum, you will find the Ask a Particle Physicist segment. Take it away, Eugene.
All right, so the question is, are particle physicists in overall agreement with quantum physicists about dark matter and dark energy, or are there other schools of thought? Or is that not something particle physicists are concerned with? So, to answer this briefly, yes, this is the case, because let's just examine the nature of the argument, like where dark matter and dark energy comes from. Well, first of all, dark matter and dark energy are completely different things, and they're used to describe completely different phenomena. So dark matter is utilized to explain this, which is a galaxy rotation anomaly, you might call it, because you would expect from Newtonian gravity this sort of velocity profile. It's velocity of stars with respect to their distance from the galactic center. So you would expect from the visible distribution of matter something like this, but we observe something like this instead. So the velocities are too big for the gravity, Newtonian gravity, mind you, to keep these stars there. They would be just thrown away by centrifugal force with this huge velocity that they're having. So the solution that people come up with, Zwicky, Vera Rubin, people like that, so they've said, well, maybe there's dark matter. There's matter that we don't see, basically, okay? Which adds a lot of mass. In fact, it's like 3 to 4 times more mass than what we see. That's what we should have according to Newtonian gravity. I once again emphasize this, okay? So this is where dark matter is coming from. Dark energy is a completely different thing. It's used to explain the so-called expansion of the universe, which is, as you may know, we assume the universe is expanding through observations of redshifts of distant objects. So we assume these redshifts are due to Doppler effect, which means the things are receding from us, and it has been found that the farther the object is away from us, the more redshift it has, so apparently it has higher velocity. So apparently the universe is expanding. Now, if you ask me, this is complete garbage, but this is the usual explanation, okay? This is complete garbage as well, if you ask me. I mean, if Newtonian gravity doesn't work, you just come up with a better theory of gravity. You don't fix it with putting in 3 to 4 times more matter than we actually see. Like, this is a really bad solution, and it's unfalsifiable in principle, so it's kind of bad. This is kind of bad for other reasons, for logical reasons mostly, but yeah, I mean, it's the whole relativity discussion, which I don't want to enter into right now for the sake of this discussion. So dark energy is supposed to be this mysterious thing which accelerates the expansion of the universe. And as you can see, dark matter is what attracts things, dark energy is what repels things, essentially. So they're completely different things. And dark energy is working on much larger scales than dark matter. Dark matter is galactic scale, whereas dark energy is cosmological scale, where it's a galaxy is a dot for cosmology, essentially. A galaxy has no size for cosmology. So dark energy is much bigger in terms of spatial scale. So, to return to your question, are particle physicists in agreement with quantum physicists about dark matter or dark energy? It's not even the realm of particle physicists or quantum physicists, as I've shown you. It's the realm of astrophysics, dark matter, and cosmology, dark energy, okay? It's not particle physics or quantum physics, neither of that, actually. However, as you might guess, if cosmologists and astrophysicists first and foremost, because dark energy, we don't know what it is. I mean, they say they don't know what it is, but because it's not even matter, it's some phenomenon, if you wish, okay, according to them. Again, I don't even think that it exists, because I think the redshifts are misinterpreted, but let's just run with the normal mainstream narrative. So dark energy is some property of space-time, if you wish, whereas dark matter is actually, supposedly, it could be matter, so it could be particles. So these particles could be detected, and that's why people like particle physicists and quantum physicists are hyped about it. So when astrophysicists come to them and say, well, there might be some other form of matter, particle physicists are excited. They're saying, okay, give me monies, pay me monies, maybe I will find this mysterious and new particle. That's what they're doing with experiments like this one, for example. So they are pretty much on board, because why wouldn't they be? Particle physicists love concocting new theories, all kinds of stupid and crazy theories about all kinds of stupid and crazy new particles. So they are very excited about dark matter. So that's the longer answer to your question. So yes, in principle, it's not what they're working with in general. However, if astrophysicists ask them to search for a mysterious new type of particle, they are very gladly doing so. So hopefully this answers your question.
So that is the Ask a Particle Physicist segment of the day. So that'll be a segment every Friday, assuming all goes according to plan. If you want to submit questions, the deadline is by the time I get up on Thursday morning. When I get up on Thursday morning, I send the question to Eugene. Eugene, he might make a video, he might make audio, he might just send a response in text form. So far, he's been sending videos, so we're okay with it. Now go over to Eugene the Philosopher's page and press the subscribe button. Otherwise, there will be ramifications. There are all kinds of different videos about all kinds of different things. Some are about science, some aren't about science at all. So check it out. Eugene the Philosopher. Subscribe to it today. Congrats once again to Eugene for getting over 500 subscribers. Next step 1,000 and a monetized channel on YouTube. Eugene. Well done, sir. Well done. Continuing on to coronal mass ejections. It's time for coronal mass ejections. Since we've got them arriving, seems like a good time to cover them, I guess. It's always a good time to cover them. So here are yesterday's CMEs. That's 106 frames. Here are 77 frames from today. And guess what? There might be yet another one with an Earth-directed component. Another kind of a stealthy one, actually. So you may not be able to recognize it there. That's okay. We've got more footage for you. Let's include the C3 as well. So let's get a little closer. And it looks like just after midday today, I think there was another Earth-directed CME. So starting out the month of December right with major geomagnetic storm activity and additional coronal mass ejections on the way. So it's not looking to end anytime soon, folks. You can expect CMEs to continue showing up into December 4th. Yeah. December 4th, another CME on the way. So, coronal mass ejection impacts galore. It is a perfect time to be in the realm of space weather. And of course, I didn't decide to jump on a bandwagon, folks. Just so you are aware, I almost majored in cosmology in the mid-1990s. I left college to pursue the sport of cycling. So then I came back because I noticed that there are some things that are about to be advanced. So anyway, we'll also show Stereo A. Here comes some more CME activity from Stereo A. Here we've got the raw imagery on the left and the difference imagery slightly delayed on the right. So there's one out of the northwest. And this one that comes out of the south mostly. This is the one right after midday. It looks like two separate events. So we got this one out of the southeast. Oh, crap. So we're missing a difference imagery. All right. This one out of the southeast, and right before it, there's another event. Well, all right. Maybe it's not earthly directed. Let's take a look at... Oh, and before we get to that, let's take a look at our custom coronagraphs. Yeah, custom coronagraphs. You got to have it. And if you have them, you might as well show them to your viewers, right? So there's a 24-hour video. And if you look right in this area down here... Okay, that was late morning. So maybe that's not an Earth-directed CME. Let us know in the comments what you think. Here's a little closer view. I'm not so sure. That could be another Earth-directed CME. I'm pretty sure I saw a mild halo there. So multiple events here happening in succession close enough together that it makes it hard to determine whether or not they are earthly directed. I say another impact is coming on the 4th. So, I don't know. Don't like it? Leave a rage comment. We love a good rage comment. We think it's cute. And also we really enjoy the personal attack comments. Those are the ultimate best. So keep those coming. If we've made you mad, congratulations. That's on you. This is the past 24 hours in our filament wavelengths, which brings us to filaments. If you want to name filaments after living people, do it over on Twitter, x.com/smashomash. Join us over there. Thanks to our one new follower in the past few days. Will you be our 500th? I don't know. Anyway, here come a fantastic series of images from Cerro Tololo, Chile. Look at the filaments, and let's stop this on the last frame here and do a brief count. So there's the current filament situation. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at least 11. So once again, nearly a dozen filaments on the Earth-facing portion. You could say that one right there is 12. And yeah, massive plasma filaments here, defying gravity, suspended by magnetic fields on the closest star. There's a grayscale imagery, some prominences there in the southeast and in the northwest. So that's what's going on. And before we get to bonus features, here are the past couple of hours from the GOES 18 SUVI. And once again, the most likely place to see a large flare would be right in this area. Here come bonus features. First is satellite charging hazards, and we have some. Some significant surface charging hazards over the Middle East, northern Indian Ocean, India, parts of Southeast Asia. Surface charging hazards are when low-energy electrons are building up on the outside of spacecraft. So that's where the charging hazards are. Some communications errors could happen from that. No likely satellite damage from that. GOES electron flux here, cratered, exactly as we forecasted. Yesterday we said this would be cratered when the geomagnetic storms arrived. And there you go. It is actually an erroneous reading. We won't get into the physics of that. It is the daily space weather after all. There's the one-year graph to contextualize the electron flux. The electron flux for the past year for the greater than 2 mega electron volt or 2 million volt electron fluence. Here's the forecast model. And the next update should be below the forecast. So the green boxes are the forecast. The yellow diamonds are the observation. We'll also show the F-layer of the ionosphere. And here is the F-layer in all of its raw vibrational frequency. You'll see a lot of low frequency on the ionogram, showing up right as the geomagnetic storm hits. And that is the ionosphere puffing up. It gets taller as well as shallower, so it gets bigger in both dimensions. It gets taller and lower at the same time. It puffs up is the best way to explain it. So that's what's going on at about 300 kilometers of altitude in vibrational frequency. And here is the anomaly in megahertz from the 30-day median. So lots of red, especially in the southern hemisphere. That's called geomagnetic storm conditions. Here's the latest image. That's 2300 universal time ionogram and 2300 universal time anomalygram. A great example of the South Atlantic anomaly right here, right over the South American continent, right where you'd expect it to be, as it's been in place there for years and years and covered on the channel quite stably, except for one short period. Next, the WAM, which is the whole atmosphere model. That is total electron content and anomaly on the left, maximum usable frequency on the right. And we'll also show total electron content by itself. That is, for you new viewers out there, free electrons from about 12,500 miles of altitude down to ground level. That's where your GPS satellite is located, the inner portion of the outer Van Allen belt. It must communicate through the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere to get the signal to you. That causes signal refraction. And here are the most likely places to see said signal refraction. And here's the anomaly in total electron content for North America. Looks like a bit of a short run there. What's up with that? So there are definitely some errors there, some missing data. And let's move on to show the latest imagery. There is the latest magnetogram and intensitygram, SDO continuum. And let's get to our meteorology segment. We're going to start out our meteorology segment today, folks, with total cloud water. So that's a total cloud water from nullschool.net. We've got a lot of moisture here over the eastern portion of the U.S. That's why I'm showing it. Total cloud water, one of the many features available on nullschool.net. Another one you can look at is space. If you click space, it'll show you the likely places to see the aurora. And Iceland is currently the aurora capital of the world. I mean, that's the place to be right now. Some fantastic aurora likely visible there in Iceland. And of course, we showed some earlier in the video on webcam. Let's blast through the rest of our meteorology segment. We'll pick up speed from here. So here are the surface winds of the eastern world. These are the jet streams. Jet streams of the central world. These are the surface winds. Like sands to the hourglass of time, these are the surface winds of the western world's lives. And these are the jet streams. That's what's up. Here are clouds and fog for the Americas as Brazil clouds up over after sunset every night. And what is up with that shadow? Look at once again. Look at that. Is it an alien spacecraft or what, folks? Look, right here. Right? There it goes. You see that? Look, right there. What's up with that? I don't know, but it's pretty weird. I don't know what to tell you. You spot stuff on the data, you cover it, and if nobody sees it, too bad. That's on whoever's censoring the channel. Anyway, here we've zoomed in on the Gulf and the eastern U.S. since there's lots of moisture over here. That is what's going on with clouds and fog. Not a good night to see the aurora over large portions of the U.S., unfortunately. And here is our precipitation type, and look at all the mixed precipitation. Rain and wet snow and even some freezing rain in some places and some wintry mix. Yowzers. Lots of moisture. A pretty bad night to observe aurora over the U.S. Here's our weather.gov map, and look at all the winter storm warnings there in pink. There is the key if your location is lit. Weather.gov is the location. Weather.gov, folks. I don't know whether or not you'll view the website, but weather.gov is the URL. Here come forecasts. Forecasts for you. The GFS 72-hour forecast for pressure and precipitation shown here. Next, the GFS forecast for total accumulated precipitation. Since floods come faster than snowstorms, check it out. Look at the insane rain totals there. 6+ inches of rain in portions of Oregon and Washington. That is what you call moist. Dag. 6+ inches, folks. Also, parts of Alabama and Georgia expecting some heavy rains, but not like Washington and Oregon. Especially Oregon is going to be kaplastered. Hey, Portland, get your hip waders ready. You're going to need them. Dude, that is hardcore. Next, total accumulated snow depth change in inches. Heavy snows come into places as well. Even the hot air capital of the world, Colorado, is not able to escape snow. Some areas with 20 inches coming to Colorado. All that hot air coming out of the whatever state, the hot air state. If Colorado could be a blimp, it would fly all the way to space. Temperature anomaly forecast is next. There it is. Temperature anomaly in degrees Celsius. We've got some warm temperatures coming to the eastern U.S. Some areas there expecting like 16 degrees above normal. That's degrees Celsius, so those are big degrees. 72-hour GFS temperature anomaly forecast. We'll close out with lightning. We had some lightning around the Gulf states. Here's a real-time lightning map from lightningmaps.org. We've got about 160 strikes per minute right now. And we may have some terrestrial strikes here just southeast of Houston. Hey, Port Arthur. There's some thunder rolling in there. Near Sabine Lake. Anyway, here's the final segment, our U.S. Doppler radar map depicting vertical motion in the air column. There's the lower 48 zoom. That's about close enough. Here is the clouds and fog scenario for the lower 48. Use a shortwave radiation map to determine if it's going to be cloudy or foggy where you are. You can do some weather forecasting, but it's the shortwave radiation map. And there is the water vapor map. And here's a recap as we bring your space weather and Earth weather together. From the photosphere of the closest star and beyond, all the way down to ground level in the lower 48. Doppler, clouds and fog. Don't forget water vapor, which should clear things up, especially if you understand atmospheric physics. Thanks for tuning into the Smash News Network. These Busted Neighbor News. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. But I'm going back to the bunker again. All the stupid stuff I heard encouraged me to jump in. Earl.